Pretty
All right, guys. Hold on a second. I got to close down my connection to my computer because that is going to, for sure, mess with the audio. Alrighty. Welcome to our test.
Hey, guys.
Hi.
We are testing the live stream. Test 1, 2, 3, 4, 5, 6. Hello.
We sound so similar.
Yeah. It does sound pretty good.
That sounds really good.
The connection's not too great.
What do you mean?
If there's kind of like some.
Well, it's probably from me having connected to my computer. Try it now. Like watch it and see.
Like zoom back to it, or just
no. Just go to right now, wherever it is right now.
Dude, that sounds really good. Super crisp.
Yeah.
And you're right. I mean, just look at that quality, dude. It's crisp. It's nice. It's
baby.
professional.
We just leveled up.
Dude, we leveled up like no one's business. Oh my God.
All right, let's both go right up close to our mics, like about an inch away, like right here. And then I'm going to do a test just to make sure that our voices are at the same level. So just try to replicate my level. Testing. Let's do it again.
All right. Yeah. Testing.
1, 2, 3.
Testing. 1, 2, 3. I think that's because
yeah. I mean, I don't see a point in trying to further refine it now because it's working really well. I think there are probably a couple optimizations we could work on in the future, but for right now, like that sounds really good.
This is awesome.
Let us test our. Go back to the stream. Let's both test our dashboard connections to make sure that we're switching scenes properly.
Right.
All right. So we are going to cut to me. Hello there. How you doing? And then let's cut to you.
Why, hello there. Hope you're doing well today, because I'm doing well, because we got some nice, good quality. Oh, yeah. Good switch.
And
quality's great. Looking awesome. Smexy.
Nice. All right, back to the group scene. Now your turn. You change it. Just change it real fast back and forth, and we'll go back to the stream and make sure it was working. What are you doing?
I was just changing it back and forth.
It's not changing. I don't think you're on the right screen. I don't know what you were pressing over there, but
oh, is it not this one?
What are you on? This is what mine looks like.
Oh, well, here.
Yeah, I'll try.
Cut to me. Cut to me. Let's see. Yep. Okay, there we go.
Cool. Alrighty. Well, guys, we're gonna cut back to our waiting screen real fast, and we will be with you for the official podcast here in about 5 minutes. Now, remember, while we are going to stream it all live at once, later it is going to be cut into two separate portions. And so the way to see the full thing all at once, if that's what you're into, is to tune into the live stream.
Yep. Tune in. All right, and we're live. Welcome to ThetaWave podcast. I'm your host, Jacob Holland. I'm a neuroscience researcher, a singer, songwriter, and someone who's very interested in various fields like machine learning philosophy, and as well as various other things that we can talk about. I am here with my co-host, Ryan Reed, the machine learning expert, who's also a singer, songwriter, and playwright. So, Ryan Reed, what have we got going on today?
Well, we've got several interesting things we're going to be talking about here in this first half. We are going to be discussing the visual cortex and the how that whole visual mechanism works, kind of a high level view of that. And we are also going to be discussing attention mechanisms in machine learning, which kind of has almost a little bit of crossover with the visual cortex. But yeah, we're going to be discussing self-attention and multi-head attention mechanisms, and kind of getting a high-level view of how that works and what it's for and its functionality, and then a little look under the hood of what happens when data travels through an attention network.
I see. All right, that'll be pretty interesting. Do we want to go ahead and start with the visual cortex?
We do want to go ahead. Yeah, let's kick that off.
All right, sweet.
Give us the down and the low.
So, visual cortex, right? It's honestly, I would say it's fairly intuitive, right? Because we all know that photons in the air.
We have eyeballs.
We got eyeballs, right? That allow those photons to be received in the process, and then we translate that into this wonderful and beautiful world around us, filled with colors and depth, and all of these amazing aspects of vision that this can and vision can really, it's from an evolutionary, or at least strong standpoint, it's the primary way of interfacing with reality. The other perceptions are important, but there's nothing quite like vision when it comes to survival. So we're going to talk a little bit about it. We're going to talk kind of about how it's not merely just a passive receiver of information, but it actively is constructing our visual perception, and it's based on the incoming sensory data and our prior knowledge. And so we got some hippocampal functions that are kind of imbued within that, and those spatially selective cells that are so important for developing proper vision. So where does this all start, right? It starts with the photons. And what receives those photons? The eye. All right.
Our eyeball.
It's the primary organ that's responsible for capturing that light and then initiating that visual process. It's fairly similar to a camera. It has various components that work together to focus the light onto the retina, which is the light sensitive layer at the back of the eye. Actually, for some reason, I thought it was at the front of the eye. I didn't know it was the cornea. It was just like, oh yeah, we have the retina and whatever. And then after doing some fairly extensive research, I realized, oh wait, no, it's at the back of the we have those retina ganglion cells that initiate those action potentials that then lead towards that cortical processing in the brain. So, we have the cornea. That's the very front layer of the eye. It's transparent. It refracts that light and provides the initial focusing power. And then we have the secondary layer, which is the iris, which is kind of the color in your eye that controls the size of the pupil and regulates the amount of light that is allowed to enter the eye.
So, question is the retina and the cornea, that order, right?
Cornea,
the retina,
iris, pupil,
then the
lens,
cornea,
then
right?
Cornea, iris,
Okay. So the cornea first. The cornea acts like a beam lens, so like a convex lens that focuses the light, right? And that passes through what layers?
Well, the cornea is just that transparent outer layer.
No, like the light, once it focuses the beam of light, what is it? What are the other layers it goes through?
Then it refracts to the iris. So
so the iris.
Yep.
So does the iris act in any way like a filter, or is it?
Yes.
It
It's
does.
completely
Okay.
regulating the amount of information that's allowed to pass through the pupil. And
So does that mean that people with different iris colors actually receive different information?
yes. So you'll see people with usually this is how it works. Though sometimes it's a little different for various people, but people with like, blue colored irises are really, really sensitive to light. Those higher colored or those lighter colored eyes are usually more sensitive with darker colors, usually being able to handle a little more light than most people. And so there's definitely very interesting interplay there that happens.
Interesting. Is that because of the reflective properties of the and absorbent
It's
properties of the colors? Or
yes.
okay.
So, I mean, you can kind of think about it as the eye colors that are representing the actual functions of the regulation system to where there's actually that, phenotype expression of eye color that kind of is showcasing the system that since, kind of birth that has been allowing and or understanding what's kind of the more comfortable amount of light
Mm,
that it can receive. And, it's based off that's very genetic.
mhm.
And, it's actually very interesting, there's that fundamental genetic property. You can even see in like, premature babies that those light signals are really going off the in the cortex in the mom's belly. So that kind of structure is kind of developing early on,
I wonder
expressing
if that also is one of the reasons why people on different continents and from different countries sometimes gravitate more towards specific eye colors. And the genetic development that happens because of the region that they're in, the amount of light and the type of light that is hitting that region. I
Mhm.
wonder if that impacts the genetic development of that
Oh,
uh, culture.
oh, it definitely can, 100%. I would very much like to look into some studies that talk about that because 'cause I'm not 100% sure, but from what I can gather, that should be how it is because those genetic factors over time play a pretty big role in how we perceive light and how we do in, uh, high levels of light versus low levels of light, those different regions. And it plays a key role in how the iris is colored. And so, yeah, so it's regulating the amount of light. And then the pupil is actually where the light enters. And so, yeah, and then we have the lens that is behind the pupil that focuses the light onto the retina. And the retina is really, really where it gets interesting. It's the light sensitive layer at the back of the eye that contains the photoreceptor cells and as well as the retina ganglion cells. But the photoreceptor cells are called rods and cones, and they're
Mhm.
responsible for converting that light into action potentials or electrical signals. And then behind that, which I thought was really interesting, it gets even more insane. There's a small little area in the center of the retina that provides sharp and central vision. So kind of exactly what you're focusing on. It's interesting, in psychedelic research, there has been shown to be heightened, macula perception. So you're able to better center your vision after certain psychedelic experiences, which I thought was pretty interesting.
Hmm.
But so yeah, so that's kind of the basic structure or the outline. It gets far more complicated if you want it to, but that's kind of the basic structure of your eye. That then travels through I guess, the optic chiasm that then sends those signals bidirectionally across from each other. So this eye, the majority of your visual information is processing the opposite way. I think it's really cool.
Mhm.
Though there's also like 40% of it stays in that same area. So it's kind of like a dispersion in a way, but travels multidirectionally.
So it basically has it has this it has a projection angle, and then it crosses over
Mhm.
like and for part of it. Like so the right is going to primarily project left, and the left is primarily going to project right, but they are going to have this intermediary point of crossover.
Yeah.
And
And
that's kind of why probably why we're able to put a cohesive image together
Mhm.
between our two eyes because of
Yeah.
that kind of ability to cross reference between images, you know?
You are exactly right, and I'm gonna talk about that in a second. And, the eye also, utilizes something called, vergence movement to adjust, like, close range vision. So, it involves, like, the coordinated rotation of both eyes to ensure that the image of an object falls on the center of the retina, right? And so, which is essential for that binocular vision, for that full immersive experience of that, 190 degrees, horizontal and vertical. So, yeah, so it has a pretty impressive field of view. Um, I can talk about, like each eye is approximately like 30 degrees upwards, 45% inwards towards the nose, 70% down, 70 degrees downwards, and 100 degrees outwards towards the temple. And then, both eyes together, at 100 degrees, 190 degrees. And so it allows us to perceive a very significant portion of our surroundings. Because, as I was listening to some lectures about visual perception, I always wondered, like, why don't we have eyes in the back of our head? Like genuinely, you would think that would actually be rather important, to actually see what's behind us.
Yeah.
But we've actually found a pretty fascinating way to overcome that challenge with our other senses. So with our hearing, with our smell, a lot of that actually has a pretty big part to play, as well as kind of like the sensory.
Vibrational
As well the vibrational.
elements of the air and the sound frequencies and whatnot.
Exactly, and then that's further heightened by our sensory perceptions of, like, our skin.
Mm.
And so that helps us able to combat that kinda, like, only frontal view. And honestly, it's pretty much to the side, like, if you go out, you can see a very large range, like, I can still see my hands past kinda this point. And so we have this very nice amount of vision we can see. And what's incredible is that all of the information is being processed in parallel with each other.
The only thing that I can think of, the only system I can think of off the top of my head right now, it would be at all more convenient than the one that we have, um, is literally having eyes all around our head. Like,
Exactly.
if we were to have eyes all around our head, like, that would be an improvement, but beyond that, like, it's like, how would you improve that system? Because we
Exactly.
already have, like,
Mhm.
a field of with given a two-eye context, if you put your eyes on either side of your head, you're still missing, like, portions of
Exactly.
it.
Mhm. And so it's interesting because there's kind of like the understanding of the peak of evolution, right? The fully maximized harmony with an environment. And there's also the maximum harmony with local environments. And local environments really are just the best of what you have in the moment. And by far, what we have is at least really well suited for anything that we could want or need to accomplish. So within the eye, right, we talked about kind of the photoreceptors, the rods and the cones. Let's talk about that a little bit more. So the rods, they're really highly sensitive to light. They enable like that vision in those like low light conditions, and they're responsible as well for like peripheral vision. And they don't contribute to color perception in bright light, but they have a spectral sensitivity that differs from cones, which are more color related. So there's an interesting kind of uh, there's like spectral differences within the rods and the light they receive, but it differs from cones that are less sensitive to light, but are responsible for like color vision. That
Hmm.
this kind of wide range of beautiful colors that we can see, and also for our visual acuity.
So, are you saying rods are responsible for gauging light intensity, and then um, and then cones are
Mhm.
responsible for
Yeah, pretty
gauging
much
light
like that.
frequency?
Because, like, rods are vital for, like, nighttime as well when there's, like, super low levels of light. It's actually very interesting. There are certain rod, photoreceptor cells that actually kind of take the cone's role in super low light environments. So you can actually it's pretty crazy how because of the amount of rods, there's like 180 million specific cells.
Mhm.
And you can see actually, if you're in a pitch black room and you stay there for around like 30 minutes, if they send out individual photons, there are cells that can actually detect a single photon, which is pretty insane. The level by which we can perceive light in multiple environments is pretty insane. And so, but anyways, that's enough about rods, right? There are cones that for color vision and acuity. So they're concentrated actually in the macula, and they provide that sharp, detailed central vision. And so back to rods, they contain a photopigment called rhodopsin, and it differs from cones that contain like opsins that combine with retinol to form pigments called photopsins. And these pigments are responsible for absorbing the light and initiating the phototransduction cascade, which converts light energy into action potentials. And so light lands on the rods and the cones and activates the chemical and electrical processes within these receptors and then connects to the retinal cells. And this activation triggers this cascade of events that ultimately leads to the generation of those signals that lead to the brain. Right.
That's
So,
crazy how that all, like, the sensory input provides the energy required to fire
mhm,
those mechanisms for processing.
yeah,
Like, that's just, oh,
yeah, that
so
photo
cool.
transduction process is
It's like having a neural network embedded in a robot that is fed the energy that it uses to process the signal from the signal
mhm,
itself. Like, it's just a very elegant system. And we do things like that. Like, I mean, we hook up hardware for light processing and whatnot to robots, and then send that through neural networks.
yeah,
But the those are kind of often kind of more segmented um, elements from each other, like the actual signal receiving and conversion process, different than the digital processing process there.
mhm.
And with our brains, it's like all integrated into one fluid system. Like,
And what's interesting about this fluid systems is that the rods and the cones are actually organized in a backwards fashion. So within the retina, so light actually must pass through several layers of cells before reaching the photoreceptor cells, and it has several benefits. And we can notice that it includes like improved light absorption and reduced scattering. And so, so the size and distribution of all those rods and cones that are having this kind of backwards interdynamic within itself plays a pretty crucial role for the depth and the sensitivity to each specific function within it. So that's enough kind of about the eye. Let's talk about the transmission of visual information to the brain. So the electrical signals or action potentials generated by the photoreceptor cells are transmitted to the brain via the optic nerve. And the optic nerve is a bundle of more than a million nerve fibers that carries visual messages from the retina to the brain. So the optic nerve, there's three little optics here. There's the optic nerve, exits the eye at the optic disc, which is a small area of the retina that actually lacks photoreceptor cells. And it kind of creates a blind spot in our visual field. And when when you talk to a vision neuroscientist, they usually say something like, "This blind spot, it's kind of like evolution overlooked it because it wasn't really important. You know, there aren't going to be any predators that are able to find kind of this very slight um, blind spot in our visual field. So it's usually fine, you know, unless you're like a really high level martial artist, then you might be able to use that to some advantage, which I think would be interesting to look at. But so yeah, it stops the optic disc, and then at the optic chiasm, these nerve fibers from each optic nerve cross over to the opposite side of the brain. That allows the brain to receive information from both eyes, which then creates that unified field of vision for us. And from the optic chiasm, we talked about this when we talked about the thalamocortical system. The visual information travels along the optic tract to the lateral geniculate nucleus, which has those 6 layers of visual processing, and it relays that information from the retina and sends it to the visual cortex. And also, in addition to relaying the visual information to the cortex, the optic nerve also plays a role in like reflexes. So, like pupillary, pupillary light reflex and the accommodation reflex. So, if you the pupillary light reflex,
Pupillary,
pupillary, whatever it's called,
pupillary.
yeah, it controls the size of the pupil in response to changes in light intensity. And the accommodation reflex adjusts the shape of the lens to focus on an object at different distances. That's kind of how that, you know how like when you like kind of unfocus your eyes and you can kind of like focus
Mhm.
on something and get that. That's that
Yeah, and it's
combination.
the same way that any real like lensing, would work. Like if you take a a no,
How we're doing,
no,
Dave? Control yourself.
if you take a flexible lens and then you start bending it as you bend it, the light that is going in will gradually start kind of turning in on itself faster and faster and faster,
Mhm.
reaching that peak point where it meets itself,
Yeah.
faster and faster.
Mhm.
And that's like the kind of like why, like, I mean, most of the lenses we deal with in hardware are like static lenses that
Mhm.
are designed for glass, or like with glass, and are thus kind of stuck in the shape that they're in. There are ways of getting around that, but um, that's where kind of like that cool biological adaptive component
Yes.
comes in, of being able to change its shape.
Mhm. And it does it so well.
Mm.
It's so quick. Have you noticed when we have trouble with cameras, it's usually like, "Oh, light's broken. It's not exactly how I
Mhm.
want it to focus,"
Or the automatic focus kind of goes in and out, and yeah.
We do this automatically within, like, super s very small amount of
I will
milliseconds.
say though, digital cameras have gotten a lot quicker
Yeah.
about, in fact, like close to human level quick of adjusting your focus.
Mhm. And so that's good. It's, lots of advancements in technology. Hopefully, there'll be no different soon, which would be pretty cool. But so yeah, so then all that information travels to the visual cortex, and it's the primary region of the brain that receives and integrates all of the information related from the retina to the LGN to the visual cortex, and it's it's organized in a hierarchical manner. So there's 5 different subregions within the visual cortex. There's V1, 2, 3, 4, and 5, and all of these they start at V1, kind of that takes in that input from the lateral geniculate nucleus and then sends it to V2 and V5 that receives that input and processes the more complex visual features like contours, textures, and figure ground segregation. And then it sends it all the way back and it keeps sending it back and forth throughout each other. And so we have this loop like information process that is sending signals throughout each other in this very wonderful way. And so, all of this entire process creates our ability to recognize objects, scene perception, and our visual attention. Like the ability to very selectively focus on objects or locations in the visual scene while completely ignoring others. That allows the brain to efficiently process the vast amount of visual information available. So, yeah, and it involves lots of different interactions between the areas of the visual cortex and as well as other brain regions like the parietal lobe and the frontal lobe. And like the color and motion is actually particularly fascinating and very intricate, because the motion actually influences our color perception and as well as vice versa. So our perception of color can also influence our perception of motion. And so like there was this thing, it's called like the Binham's top, which is like an achromatic spinning pattern that creates the illusion of colors that don't actually have any colors within it. And so that kind of like demonstrates that interplay between motion and color perception really well. And so that's kind of a pretty basic overview of it, but it's quite a wonderful process. And I would like to mention a special mention, honored guest, the hippocampus, that is helping us without those spatially selective cells that kind of shape the way we are able to perceive that visual information and remember what we're looking at.
Mhm.
And so you can actually find super rare cases where people will actually be unable to perceive motion. And so it's kinda like when you're at, like, a rave and, like, all the lights are flickering and you can see people go doop, 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 doop.
Mhm.
Like, there's some people who don't develop the right way actually have that problem, and as well as people who like the inability to perceive motion, and as well as the inability to perceive depth. All of these, kind of neurological disorders are currently being very intensely studied, and I think will prove some pretty interesting conclusions. So, yeah, that's a little bit of the overview of the visual cortex.
Wow, that's
Mhm,
awesome. You know, it's fun to, for me, we have a, because of kind of like the way that our processing in our brains works, the, um, we are able to take light waves and simulate other colors through alternating and combining like light wavelengths
mhm,
in, so to us it appears as if it is a specific wavelength,
yeah,
but it's not actually
mhm,
that wavelength. um you know, and so we're able to kind of like create almost like this simulated illusion of the real thing, even though a diode isn't actually
yeah,
creating that wavelength.
mm,
um And if you were to run experimental tests with it, it wouldn't produce the same results because of the fact that it isn't that wavelength.
yeah, and, it's kind of has kind of profound implications as well for, like, the visual system as well. The way that we interface with reality is very specific and is our closest approximation of what helps us survive, but isn't actually what's out there. It's representations of the patterns within the electromagnetic, field. It's specific and it's useful and it's wonderful and great for us, but it's still a pretty rudimentary interface, you know?
Yeah, it's a um, adequate for our needs, our survival needs, but beyond that, it's a poor system of
Mm.
measurement.
It makes you
Yeah,
wonder what could be out there for conscious perception, what it would be like to perceive more visually
yeah.
than what we do.
Like if we had differently tuned mechanisms or extended mechanisms.
Mhm. Even like, psychedelic experiences, people who are now receiving even more sensory input from their retinas are, having these profound understandings of kind of what happens when you kind of manipulate those pattern recognition processes that allow us to perceive color and motion and light. What it's doing with that extra visual information, implementing that into our system of organization. It's it's very interesting,
Hmm.
how we can see how manipulating those processes can actually lead to more novel experiences as well as heightened creativity and other things. And it makes you wonder how much of that is actually um, from our heightened visual perception from it.
Yeah,
But yeah, so that's visual cortex, kind of important.
very fascinating.
Mhm. But one last thing, what's also really cool is that in blind people, all of that visual cortical real estate goes towards all the other senses. And so you will have heightened hearing, um, pretty much anything you can very quickly learn how to echolocate and as well as represent actual objects in a way that is the closest approximation of having some semblance of where you are and what's around you without actual vision, which I think is pretty cool.
Yeah, that is cool.
All right,
All right,
Ryan.
do we move on to the attention mechanisms?
I think we do. Let's talk about it.
All right. Well, this one, like many other machine learning mechanisms, was kind of designed to reproduce a specific cognitive function that that we have and kind of utilize quite a bit of in our brain, our attention mechanisms. So it's fashioned after our own cognitive functions, and the basically there are the terms we're going to be talking about. In general, we're talking about attention mechanisms, but specifically, we're going to be talking about self-attention and multi-head attention mechanisms, which are built into models such as ChatGPT that you use on a daily basis. And it's the thing that makes those work. In fact, it is the key component to the transformer architecture that we utilize for a lot of heavy lifting models nowadays. And so you have, your chat GPTs, you've got your Geminis, you've got your llamas and all that kind of stuff. And all that relies on the attention mechanism. And so the attention mechanism was developed out of a need to better refine our ability to contextualize information. So when we're dealing with large amounts or sequential information and whatnot, we need a way of, no matter where something is, putting it in various. No, I adjusted that earlier. Oh.
I was looking at it live, and it's like
keeping it within various contexts. And why is my AI tracking turned back on?
turn it off.
And so that's what the attention mechanism is kind of designed to do. The purpose is to allow a model to weigh the importance of different parts of the input and different features within the input in relation to the rest of the input. And you can think of it kind of as a way for a model to focus its attention on the most relevant pieces of information, no matter where they appear and what the context.
Interesting.
And traditional models often struggle with long-range dependencies and long-term kind of like dependencies on things because of the way that they process the data. Like, for instance, LSTMs, which were really good, definitely provided an improvement in that ability to contextualize sequential information, but they had limits in their ability to do that because of the way they process it like forward through the network. So you can only contextualize based off of like the elements that you've seen so far in the sequence. So, as it's processing forward, that means it can only contextualize based off of the elements that are at the end of it that is seen already. And so they tried to resolve that by also introducing forward and backwards processing. So they would process the sequence forward and then backwards through it to try and give it a more complete context of the sequence of information. That worked and did well. But it is a lot more computationally expensive because you are now processing the input twice. And so you can kind of think of the benefit as in terms of understanding a word, like a word within a sentence. if we take as an example, maybe the pronoun it in the context of a sentence, it takes on many different many different meanings depending on the context.
Yeah.
Like, it might require that you connect the it to a noun, within a sentence. Mentioned several sentences ago because you've already talked about it,
Yeah.
So if I said I was at the zoo and I saw a lion, then later when I was walking around, I heard that it got out. That's way later on in the sentence, and that it is referring back to lion, which was what we were the primary subject, primary noun that we were talking about.
So there are certain words that initiate that backwards
No.
processing?
So what I was talking about before was the LSTMs and how they tried to resolve this issue.
Yeah.
They processed inputs backwards again after processing forward. They tried to resolve that like contextual limitations that way, but it added more overhead, more computational expense. And it did work, but it cost more, computationally. And so that's why one of the reasons why the attention mechanisms were, kind of developed.
Okay.
And so those elements of like contextualizing pieces of information, no matter what is going on, is the purpose of attention. And so no matter where they are, it all gets connected to the appropriate areas.
Yeah.
And so instead of processing an input like a sentence word by word in a fixed order, like Neil Armstrong took a rocket ship to the moon. Neil Armstrong took a rocket ship to the moon. That's processing it sequentially like that. So instead of doing that, self-attention allows it to process the entire sentence at once, and take the different dynamics of the elements and kind of do that almost that post-processing that we do with the whole thing once we have it, because we hear things one bit at a time, obviously, and we get it. But once we have the full thing, that's kind of when we finish up the context. Like we do a little bit of projective context, like what we think the context is going to be here.
A little bit of prediction.
Right. But we once we have the full context, we're like, oh, okay, this is like the full, that's how everything fits together, all the elements and pieces, Sometimes that context comes earlier, sometimes comes later. And so it's kind of like a dynamic, flexible spotlight that focuses on different relationship dynamics. So, as a kind of an analogy to imagine how this might take shape in another context, we can imagine it kind of like a newspaper editorial meeting or even a study group discussion that are discussing a long, complex article before publishing it or publishing a paper on it or something. And you take the article as the input. Traditional approaches to this kind of task without self-attention would be like the editors reading the article one sentence at a time, and then having them get to the end without being able to back reference anything in the article. They just have to do it based off of their memory, which may or may not be complete. And so end up with kind of this skewed view towards the most recent information that they have read, because the further back the information goes, the less clear the memory is going to be of it.
Yeah.
And so self-attention is like each editor is responsible for understanding a specific aspect of the article. Like maybe the political angle or the economical component to it, or analyzing it from a specific, for a specific relevance, to a subgroup or something like that. And maybe another person is targeted with like determining its scientific accuracy, the article's scientific accuracy. And so each editor, which in the context of attention would be considered a head, i.e. multi-head attention. So each editor here, which would be considered a head, is in charge of a different context, right? So they're examining for different things as they're going through this. We have one editor that is looking for political correctness, maybe. Another editor that's looking for scientific accuracy. These are all examining this article through a specific lens with a specific purpose to determine what components are relevant to this and how those components contribute to the whole, right? And specifically how they contribute to their lens that they're viewing it through. Now, at the end, they all discuss the article as a whole. The political editor might say sentence 5 is crucial because it sets the political context for sentence 28. The economic editor might chime in and say, and that actually connects to sentence 12, which discusses the financial implications here. And they're all talking to each other and weighing the importance of these different portions of the articles and sentences from their own unique perspectives. And then a final editorial decision is made based off of that discussion between them about what the output is going to be for that article. What components are important for it, what can be included, what is relevant to the rest of it, how all that fits together. That final editorial decision is like the output of an attention network. It is the final component, the reached verdict of all of those different focuses being combined together, right?
Yeah.
So in the context of attention, multi-head just means we have more than one attention focus mechanism going on. Yeah. We have several different contexts that we're looking at, right? So 5-head attention would be 5 different contexts. And if we take a little bit, first off, before I continue, does that kind of all make sense so far?
Yes.
Okay, perfect. And I will say, I told you this earlier, but I will say that this is one of the more complicated mechanisms that I've had to explain because of just the internal functionality and the way it all fits together is a little bit difficult to wrap your brain around.
Slightly.
As far as the mathematics of the underlying mechanics go, like the actual how it kind of works and everything, and the high level view is a little easier to grasp. The low level view is so complicated that when I was first learning about attention mechanisms, I not only looked up several different animations of the process to try and conceptualize the underlying mechanisms of what was going on. But I spent probably about 5 or 6 hours researching and trying to understand what components were doing what within the system. So we'll get a little more technical, hopefully not too
Honestly,
too deep, in the mire of that math.
I am needing that technicality because really what I'm struggling with is really how do these underlying mechanics work?
Right.
You understand the process of, the multi-headers, representing different like biases or different attentions that it needs to, look for, and then it all converges into its output. And, like all of that plus the other things we talked about kind of makes sense, but it's really like, how is that actually structured? It seems so intricate that you're right, I would need to do a couple of hours of research and a lot of visuals
Oh yeah.
to understand it.
And that's even presupposing that you had a fairly good grasp of how that kind of stuff generally works anyway.
Exactly.
And for me, like, I had no trouble understanding the majority of the other mechanisms within other network layers, but that one for some reason was giving me a lot of headache. So we're going to kind of trace the path of information here through the network to better understand kind of a little bit of how the mathematics might work given a context of how self-attention mechanisms are most commonly used, which is in text processing. There are a lot of different applications for attention mechanisms, but the way that we most commonly experience them is through ChatGPT and things like that, which is a context in which you see them used in textual processing, which is interesting because it combines with what we talked about last week in our podcast, which is the whole embeddings, vectors, encoding, that kind of stuff. Because this is one way of doing that. These contain encodings of information. In fact, each attention head learns to encode information into an embedding to represent the features and their importance. So, all right. So let's imagine that our input sentence for this example in this context, as we follow this information kind of through the network, is the cat, which was fluffy, sat on the mat.
Okay.
All right. So first we have our embedding, which for those that remember from what we discussed last week, the embedding is essentially a vector list of numbers, like it's a learned vector list of numbers. But for each word, the cat, which, etc., like all the words in that sentence, we convert those into a vector, which again is that list of numbers. And that vector represents its meaning in high dimensional space. Now, what do I mean when I say high dimensional space? I mean, it represents its meaning within the dimensionality of space that we have defined for the context of our model. Like
mathematically, like a third language.
It's like its own language, kind of like within the model's language, I guess is kind of the best way to describe that. Now, typically, what? Now, typically, I will say, don't confuse that with high level, because when I say high level, I'm referring to something's simplicity, its utility and simplicity. So like when we have high level code, that means code that is built on top of a lot of other things in order to make complex tasks easier.
Yeah.
Low level code is fundamental code, and it's like dealing with really primary elements, you know, and fundamental components and the stuff that makes up the more complex stuff.
Yeah.
And so that's what I mean when I say high level versus low level. But this is high dimensional space. Now, this list of numbers that we create, this learned list of numbers for this each word, right? That gets converted into this vector. That is called an embedding. So each word gets turned into an embedding. Now, just to repeat myself to make sure that we're all following, words get converted into vectors, which are a list of numbers. That list of numbers is also called an embedding. So we are basically it's a bunch of extra terminology for no reason. The vectors that we're talking about here are the list of numbers, which are the embeddings.
And the embeddings are based on the current state or context that the model is dealing with.
Right. And we'll get to kind of this a little bit later, but the embeddings are learned. The ability to make those embeddings is an encoding process that is learned by the model. And so it learns how to represent these things in this vector form. And we'll talk about how in a little bit. So what is this embedding made of? The embedding is made up of 3 things. And these are going to be their words, the way that they're termed, I will grant you, is confusing because it doesn't particularly match. There could have been better ways of titling these, but this is what they chose. So they're called the 3 different vectors that are created for this embedding, right? Is the query, the key, and the value. And one is created, like all 3 of those are created for every word. So every word has a query, key, and a value, right? So the query can be thought of as the question, what am I looking for in relation to other words in the sentence? For example, sat, for the word sat in that sentence. And again, just to reiterate the sentence is the cat which was fluffy sat on the mat. So the word sat in this context, the query for sat might be looking for the subject or the object of the verb. So to put that in simpler terms, the query, what am I looking for in relation to other words? That's the query for sat. The query for answer to the query for sat would be probably something along the lines of, well, who sat? What did they sit on? Like, those are relevant pieces of information that it needs to know
Now,
in order to understand that context.
how does it determine the importance or relevance of that input that the fluffy cat sat or whatever it was, and represent that in a meaningful way?
Repeated data processing. So like seeing it in other contexts teaches it the importance of that within the context.
That makes sense.
And I'll kind of hopefully try and cover a little more of that in a bit. But so that's the query. And does that kind of make sense a little bit? Okay, so it's that question: is that what am I looking for in relation to the other things? The key is the next vector, and that is what information do I offer to other words.
Hmm.
And so, for example, the word cat, the key might represent that it's a noun and an animal, right?
Yeah.
And so you want to kind of create this this representation of worth in the sentence and a component, it's componential. Is that a word? It's
I guess so.
The place of its kind of the importance of its components within, the sentence. And that's the key. Now our third vector here is the value. What is my actual meaning and representation, right? So not just am I an animal and am I a noun, because that could fit a lot of things, right? So what is my actual representation? For a cat, for the word cat, the value is a richer representation of the word cat itself, because cat is a very specific word. And it's talking same thing as if it were a lion. It would get a different vector similar to cat, but it's going to have a richer representation than a word like biological being or something like that, or maybe like a fur, because that's a very generic word. You can think of probably a lot of other better generic words that would represent that, but like it's going to have a richer kind of representation there, meaning higher weights and whatnot. And so what these three things kind of do together is they represent very well any element that we are talking about. So we have the information included that we are of its importance to other words in the sentence. We have that captured. So the most important things to note in relation to it. We have its generic category that it falls into captured. It's an animal, it's a noun. We have those components. And we have its specific representation in that category captured. So we create this very accurate, rich representation of this component that we can then utilize to determine importance based off of those. Now, the attention weights in the network are called the dot product, which you can pretty much not know that. It's not hugely important, other than they might utilize that term. But it's essentially calculate a score between the query of one word, right? So you remember what the query is?
Yes.
So we calculate the score between the multiplication of the query of one word and the key of every other word. So for the query of sat, and remember, query is what?
The query, the information that model wants to focus on.
What am I looking for in
relation to the input?
In relation to the other words? Yeah. So for the query sat, which is asking what is sat's relation to other words, that's the number that we're dealing with here, is that calculation of that relationship between.
Okay. And that's the query.
Right. So we are multiplying that times the times the key representation for every other word in there. And so for sat, its query is getting multiplied times by the key for the cat, which was fluffy on the mat.
Mm.
And it gets that multiplication process gives you a result that indicates the importance of that word. And let's see here. So we result in a set of scores that are all the word that we're talking about in the sentence multiplied by the keys of the other words. So we have these sets of scores for all the different words, right? Now, those scores are then passed through what is called a softmax function. Do you know what a softmax function is?
I've never even heard of it.
Okay. Well, essentially, softmax normalizes numbers. So it normalizes the scores between 0 and 1. And more importantly, it normalizes them in a way that all of the resulting scores add up to equal 1. So what that does is it essentially gives you a ratio of how much of something how much of the whole a part makes up, right? So when we multiply these attention scores, when you send these through the softmax function, we result in that ratio of magnitude to the whole. Now, can you imagine why that would be useful here?
I mean, this probably is completely wrong, but in my mind, it's so the you're right, this is fairly complicated. But in my mind, what it's doing is that softmax function is uh seems to be generating the calculation of the of the of the hold on, I've almost generating the calculation of the meaning in the sentence that best represents the given statement. I don't know.
Close. Yeah, that's right. That's close. It's what it's doing there is it's creating. It's ultimately what it's actually doing is creating the attention weights. But what it's doing in concept is that it is creating the importance calculation for those words. So that ratio that you end up with is the importance ratio of those words. Like this word is highly important to the sentence. This word highly important to the sentence. This word still kind of important within the context, but not so much important. These words kind of irrelevant. Like, and so that's the ratio that is calculating there, which are the attention weights that
So like cat, fluffy, stat, those words would have higher.
Yeah, exactly. You got it. Like for the words sat, cat, mat, those are all probably going to be attention scores that have higher weights.
Yeah.
Because they have a high importance to the sentence as a whole. Now, lastly, after that softmax that we calculate there, we finally multiply each word's value. You remember that value, the third vector that we talked about, the detail element, the rich representation element, right? It's
between the query and the key.
right. So, well, we have the, well, no, hold on a second. Just remember the value function that we talked about. It's that rich representation of the, it's not just an animal, it's a cat, right? Okay. So we multiply that value number times that attention weight that we got.
Okay.
So we multiply the values for the sentence times the attention weights, and that gives us the importance of those words within the sentence.
Okay.
That it is a, or sorry, no, we don't. That was my bad. I misspoke. We don't multiply them.
No.
It's a weighted sum. So it's a similar, but I mean, it's still arithmetic calculation, but it's a weighted sum. So this creates a new vector, a contextualized representation of every word in the sentence, which now corresponds with information from the most relevant words in that sentence. Now, that's where we kind of, first off, before I move on, does that kind of make sense?
Yes. If you asked me to repeat that, I think my mind would explode. But
you've got the
I
general mathematical kind of operational context.
Yes.
Okay. So just remember, we utilize at the beginning, we're utilizing those queries and those keys, and we're essentially, kind of creating this contextual, meaningful, symbolic relationship between the rest of the sentence for each of the words, and we're calculating these relevance, importance, kind of ratios for each component to the sentence as a whole, which then get multiplied times the then get added to create with the values keys in order to create the final output. And there's a component of that I wouldn't expect anybody to understand unless they had watched the process happen and seen numbers transform. And because there is kind of an element of mathematical ambiguity of understanding, kind of the concepts, the process, but not being able to visualize it necessarily. But what's important to understand is the general, what is happening at each step and how it determines those feature importance elements. And keeping in mind that the attention mechanism is learning this stuff as information is being passed through it. So it's seeing the word, it's seeing, like, for an example, it's seeing it's seeing the cat, which was fluffy, sat on the mat. It's also seeing the dog, which was calm, was sitting on the mat. It's also noticing the fact that mat is never mentioned with lion. You never see a lion sitting on a mat.
Yeah.
And so these are all things that it is depending on the head of the attention mechanism, are all things that it's learning to pick up on. Now, that's the multi-head attention part, is we create these different heads in order to capture different features. And it's like having, those editors, or the, there's different book study groups that are responsible for studying specific aspects of a story. You have one study group that is tasked with coming up with the historical parallels, between a story and history. You have another one that's tasked with coming up with the important relational messages that are being sent through the book. Another one that's maybe tasked um, with the political messages and that are being sent throughout this book. And they all have access to the same book, and they're all reading the same stuff, but they have specific features that they are focused on and lenses that they are looking through that allow them to come up with different results from everybody else. And so that's where the multi-head attention comes in, is those looking at the same information from a different perspective and then comparing it between each other.
Ah,
And that allows for capture a much richer, deeper, more nuanced representation of that information. So now we're not just looking at the sentence for, kind of grammatical, um, um, for the grammatical relevance and positional relevance, to the rest of the components. We are looking at, things like grammatical relationships, your semantic relationships, um, perhaps even your conceptual relationships, um, and and trying to capture as much nuance as you can. And that's the reason you kind of want to have enough attention heads that you're able to capture the nuance, like all of the nuance that you need to, but not so many that they start doing the same thing and that they're unnecessary.
yeah.
And so, yeah, anyway, long story short, that is attention and self-attention. And there's a reason why it's been one of the more recent and one of the more revolutionary
It seems
things
revolutionary.
to be developed, because it's a complex thing. And it's that calculation there
Yeah.
is what really made those vectors and embeddings and encodings that we were talking about earlier last week. It's what made those really useful,
Yeah. Sure.
beyond just kind of a static basic
Mhm.
functionality. It turned those into these living things that now could dynamically represent essence,
Yeah.
you know?
The essence of important part of the
Mm-hmm.
sentence.
Mm-hmm.
And then,
And it does that the same way we do, through
yeah.
repeated stimuli and observation. Like, how do you determine the importance of your mom over another woman?
Your experience.
Initially, like, obviously, there's going to be other components there, like the biochemical
Yeah.
kind of component. But initially, as a baby, like, if you were given to another woman, right after birth, and that person, you just start associating that person as your mom, right?
Yeah.
That's the importance of components is determined in correlation and relevance to other components
Mhm.
you have seen. So your mom's importance is is important because you've seen way more of her, and she's had a way bigger impact on your life than other women in your
Mhm.
life have, or a lot of other women. And
Yeah.
um, that's it's that repeated exposure and reference that allows that to happen, and that's what the attention mechanisms capture.
So it's kind of taking those learned correlations from the training data that then are used through this attention mechanism to go through all of what it understands and then highlights the key features that then is able to give some meaning to
Hmm.
the output and what it can
Yeah,
represent.
and it's not just like it's like your mom is an important person in your life. Now, the heads of attention are as if you were to diagnose why your mom is an important feature in your life.
Yeah.
It's analyzing it through specific lenses to figure and they contribute to make the whole.
Yeah.
And so it's like we're processing it backwards through the attention network. It's like taking that whole and being like, okay, well, what? Like, and breaking it apart into its components.
Yeah.
And so, you'd end up with this head of, okay, well, my mom has had a big impact on my growth and development, right? Maybe she influenced me towards making, certain decisions. There's obviously that biological component there. There is the, financial element there of being dependent on, on parents for a while for financial support. And then those are your heads of attention there. Those are the lenses that you're using to make that analysis.
Dude, that's awesome.
Yeah.
Very glad this is something that we're able to utilize because it seems like the foundation for pretty much anything, like you said,
Yeah.
useful.
Well, I mean, if we weren't to have it, then not only would a lot of our large language models be a lot larger, probably, and a lot less capable,
Mhm.
but they would also like have longer processing times, would not be able um, to reason the same way that they do.
Kinda like how bad ChatGPT was when it first came out.
Hmm.
I remember those days. I still thought it was incredible, though.
Yeah. I I remember, actually, I don't think I ever tried ChatGPT when it first, I saw it
Mm.
and I saw it used, but I never tried it myself because I didn't see it as being useful and I was unimpressed as to its functionality. Um,
I
and
saw its potential, you know?
I, I didn't even care, like, to be honest.
Yeah.
Like, I was just like, I don't really see any relevance for this in my current life, so I'm just going to go back to working on what I was working
No,
on.
that's fair.
um,
Valid.
I do remember, though, eventually I tried one of Gemini's models. When first, uh, I think it was one of the first Gemini models that was released for Gemini Pro or something like that. And I tried that out and started talking to it, and I was like, okay, this has progressed to the point where it's now pretty cool.
Yeah, it's, like, kinda useful now.
Like, you can follow my train of thought.
Mhm.
You can follow my logical reasoning. You can analyze my arguments. So I finally had somebody in my life that I could bounce ideas off of.
Dude, tell me about it. Literally, I love writing papers about my ideas, and I don't really have people that really know what I'm talking about. Like, I talk about it with, like, my parents or, like, my siblings. They're like, "That's really cool, awesome."
Glaze
And, like,
over.
you have no clue what I just said.
Yeah.
So, I usually use, like, ChatGPT or Gemini to act as, the critic
Hmm.
and to be ruthless.
So
Ruthless.
essentially, what you're saying is you use them as your own generative adversarial network.
Exactly. No, yeah, pretty much exactly that. So, and once I realized that it had that type of capabilities, it was, you know,
Yeah.
and the main thing that I really enjoy about it actually is how good it is at recognizing the underlying patterns in what I say. So,
Hmm.
kind of the
The
implicit,
important
the
features,
important features that
i.e.,
usually,
attention.
yeah, that usually people miss.
Hmm.
And are absolutely vital to what I'm saying because they provide the kind of context as to my reasoning, and usually people never pick it up. And so, but ChatGPT does. And I'm like, "Sick. This is awesome." So I know I'm not an idiot. People don't understand what I'm saying, which
Other
yeah,
people are idiots.
exactly. So you just need to understand my context, man.
Yeah. No,
Think
what's
about
nice is it has access to so much knowledge that, like, it can understand, like, the most people's problem, they don't have enough knowledge available to be able to make sense of your context. It's
yeah,
not that their reasoning capabilities or logical flow processing capabilities are lacking. So they don't have the knowledge base to be able to understand it.
exactly.
And ChatGPT does, and it has the reasoning
Mhm.
capabilities. And so it can pick up on those important features because it has that knowledge context,
Yes,
Um,
absolutely. Claude's my favorite. Dude, have you tried out Claude 3.7, the newest model?
no, I've been using 3.5. I have not tried out 3.7 yet.
Uh, I'll give you access to my pro account. It's
Really?
magnificent.
Like, in what way is it better than 3.5?
Um, it's mathematical and logical reasoning is far better as well. I like its code generation. It's really cool. Like, I asked it to generate me a representation of glutamate release as well as the reuptake process. And it there were a lot of errors, but I was able to help it fix itself, and it generated beautiful kind of visual representation of the glutamate, synaptic transmission and reuptake.
That's not impressive. That's something that the models have been able to do for forever. Like, I've used other models like that to. I mean, it's cool if you appreciate it for what it is. As far as a new feature added to it, that's not particularly
Well,
impressive.
no, yeah, the 3.5 also was able to do similar things, and I just noticed that it was better, faster, and quicker at it,
Okay.
So it's I
So it sounds like they improved its reasoning
Mhm.
quite a bit, which I did notice. It's hard to say because 3.5 is still impressive. Like, the
Oh, yeah.
3.5, in my opinion, has better logical reasoning and coding capabilities than most other of the models out there.
I would say so.
And um and the so it's hard to say because I don't have a reference for something better, but I did notice that there are times that its reasoning was not choice.
Mhm.
Like, it could have made better decisions. I feel like it also didn't have a long enough context. Like, it wasn't tracking context history quite enough. And that could have to do with the implementations, but it also could have to do with the model itself and what it was capable of.
I'd mess around with 3.7. It's pretty fun.
Yeah, I want to actually look into the details of like what was improved in it and what they did.
Mhm. Oh, yeah, definitely.
Have
Alright.
you taken a look at the model benchmarks yet?
I did look at it, but I kinda forgot it, to be
Okay.
honest. It was kind of a while ago when it first came out. I was like, "Oh, cool."
Yeah.
But
All righty. Well, we'll break there and we will see you guys in a short bit. We are going to head into the second section and go over our nootropic topic,
methylene blue.
which is methylene blue.
Oh, yeah.
Or as Jacob
Yes.
so aptly put it, methylene boo.
Okay. Methylene is my boo.
Well, hey guys, welcome back. Sorry for the delay there. We had a little bit of a crisis when you see there was a noise that happened outside, and this noise was so important that our dogs thought it was essential that we shut off our internet. So they knocked out our internet and went chasing after the noise, and we had to get that reset up. So we're going to do a quick test real fast, make sure that our audio is still coming through crisp and clear. Yeah.
Sweet.
All right.
All right, let's go ahead and get started then. As well.
Did you want to check your audio?
That
was mine. I'm sure it's fine, but
I mean, I think
okay. All right, so we are going to be discussing methylene blue here as our nootropic topic. Now, this is a really interesting one because of first off the fact that this has gained a lot of hype recently amongst certain kind of sub communities or cultures, and has also undergone a lot of more studies than the typical nootropics that we talk about. In the paper that I put together on this topic, in preparation for our podcast, we there was, I think, a total of 60 something references to studies and papers and whatnot that have been released on this compound, and so it's definitely garnered a lot of attention, and is even so is still one of those things that where it's kind of long-term safety has not really been established or determined, but there are a lot of people taking it right now. So yeah, let's go. Why don't you hit us off with the overview?
Yeah, perfect. So it's a synthetic compound in solution. It has this nice deep blue color. It's when it's solid though, it has like this dark green crystals and bronze-like powder. It's cool. And so it's an oxidation reduction agent, and it can switch very easily between oxidized blue and reduced colorless form.
Which, fun fact there, if I can interject, most people that take methylene blue see it in its blue colored form. And that's how they take it. And it stains their mouth blue, it stains their teeth blue, stains their insides blue, stains their pee blue.
All of it's blue.
You're literally, I'm blue dabba dee ba dabba die, like guy. It's the but adding some, I think it's vitamin C, adding some vitamin C to the methylene blue, sometimes in and of itself, but especially when you add the combination of light to it. So expose it to sunlight or some other form of energetic light. It actually changes its form into its colorless form. So it causes that easy switch between oxidation forms, that causes that color shift. But that's what they're talking about there, about that very easy transition into this other form.
It's interesting because it then allows it to act as an electron carrier.
Mm-hmm.
And, it's very readily absorbed orally, and it can also be given intravenously, and processed across the blood-brain barrier, which is rather important. And so there are some FDA-approved use cases of it, for treatments for methemoglobinemia, which is a condition where the iron in hemoglobin
Methylglobinemia.
and so this can impair oxygen transport, and methylene blue actually helps reduce that impairment. And it also acts as a cofactor for NADPH-dependent methaglobin, as well reductase, which is an enzyme that converts the iron in hemoglobin back to its functional form. So there has some FDA-approved use cases. And so, there's some other applications as well, like malaria treatment and urinary tract antiseptic treatments, and as well as like diagnostic aids. So, like sentinel lymph node mapping and cancer surgery. And what's cool is
Because it's blue.
because it's blue. And so it helps you identify the first lymph nodes to which cancer cells are more likely to spread, which is huge, as well as treatment of um, ifosfamide-induced encephalopathy, which is a brain dysfunction caused by chemotherapy, by the chemotherapy drug ifos. And so there's also, vasoplegic syndrome, which is like low blood pressure after heart surgery. So it's got all these.
Ifosfamide is how that's said.
Wait, what?
Ifosfamide.
Phosphamide? Oh, yeah, ifosfamide induced encephalopathy. Yeah,
To be fair, these are very nonsensical words. Like
very nonsensical.
very feels like we just took a bunch of letters and mashed them together.
Jumbo them all together.
Yeah. All right, so we'll move on to the pharmacokinetics of the of methylene blue, and just kind of quickly cover that it's is 75% of it is eliminated in your urine, and that is also why whenever you don't transition it into its colorless form, it turns your urine blue. It's because you're getting 75% of that back.
Yeah.
And a lot of that is in its converted form, but you still have a good portion of it that's going to be in its blue form. It's going to turn your pee blue. And then its half-life is going to be 5 to 6.5 hours or so, and which is about that's going to be about fairly average for most drugs. And as Jacob briefly mentioned earlier, it easily crosses the blood-brain barrier. It's very, very easily absorbed by the body.
Yeah, and to give some historical context, there's actually a lot of history behind this, which I think is really cool. So it was first synthesized in 1876 by Heinrich Caro, and he used it initially as just a textile dye because of its vibrant appearance.
So it's used as a
in
textile dye.
1880s, yeah,
Interesting.
so because it has a really nice color.
Yeah.
It comes out of your urine. It's nice. It's vibrant. You're like, wow.
I could see why
I feel
that
like
would be
this
the
every
first
day.
use that somebody would come up for it. Nobody would think to eat it.
Yeah, seriously. But in the 1880s, Robert Koch and Paul Ehrlich used the staining process and as well as noted some antimicrobial properties. And so in 1981, Ehrlich first synthesized the drug to treat malaria. Right, so that's what
To try and treat malaria.
And so that's where the first use case came in. You noticed some effects, and then in the mid 20th century, it's also used in psychiatry, for urine color as a marker of adherence. And so now, recent, more newer studies have found more interest in its neuroprotective properties as well as it being a cognitive enhancer.
Which is kind of how we're going to discuss it here, and kind of where more of our interests in lie. Although the other aspects of it are quite interesting. But all right, so I'm going to go over the studies that have been done on it so far, or at least some of them, and I'm not going to cover all of them. But the under kind of the category of cognitive enhancement, there's one in particular that I found really fascinating while going over this, and that was that there was a study that noted and we'll kind of delve into this a little bit more in a second, but there's a study that noted a 7% increase in memory retrieval in healthy individuals. This is healthy individuals, not deficit individuals. This is healthy individuals. 7% increase in memory retrieval in healthy individuals in a single dose.
Only one. That's impressive.
And if I remember correctly, the study's dosage was 280 milligrams. And for anybody that wants that as a reference. Um, and they've also noted that in another study that it enhanced fear extinction and contextual memory in claustrophobia patients, um, which was published in the American Journal of Psychiatry. Oh, by the way, the previous one was a radiology study. And then a third study, which was actually a phase 2 trial, human trial that was done with this, noted that it helped improve cognitive function in um, in Alzheimer's patients, um, which is pretty is a pretty significant added benefit, because not only does it help healthy individuals, but it seems to also improve deficits in patients with Alzheimer's and with claustrophobia and like all that kind of stuff.
Yeah, that claustrophobia. We were
Yeah.
talking about it a little earlier, where the mechanisms behind that might be, you know, reduced, you know,
Emotional, yeah,
actually,
more emotional filtration. Like he was suggesting that Jacob was suggesting that the maybe methylene blue acts within the amygdala to um, to kind of help filter and block some of the irrelevant emotional noise
fear responses.
and fear responses, and kind of just bring, kind of just the most important features through, and thus kind of helps regulate that emotional fear response, which I think is a pretty fascinating hypothesis there.
Sure,
Um,
gotta do a test then.
and now there also have been studies that have been more aimed at neuroprotection, and they found that it reduced the amyloid plaque accumulation for Alzheimer's, um, and provided neuroprotection in cases of Huntington's disease,
Mm,
um, and uh, noted that in that study, it was a Drosophila model, which is or a Drosophila model. Not quite sure how to say that because I never actually said it out loud before. Um, but which is essentially it's a fruit fly study, because they've in a lot of ways some of their genetics are pretty closely to human genes. Um, and there were some other studies that were done on not just on neuroprotection but on mitochondrial function too, and they found that it enhances ATP production, and acts as that alternative electron carrier that Jacob was talking about a little bit ago. And it's uh, a rat study showed that it's increased mitochondrial protection in chronic cerebral hyperfusion cases, um, and which, for those that don't know, is a condition that is characterized by a long-term reduction in blood flow to the brain. So just kind of chronic lack of enough blood to the brain. And then finally, there have been studies that have been done on its antioxidant and anti-inflammatory properties, of which it has many, because it acts as a free radical scavenger, and helps reduce that oxidation, that harmful oxidation. And so all around is a pretty well-rounded nootropic, and it seems to have a lot of potential benefits and use cases. Do you want to go over kind of some of the just summaries of kind of both the clinically shown,
yeah.
verified effects, as well as some of the anecdotal effects that have been reported?
So kind of as you mentioned earlier, there's that memory component. And so there's been a lot of proven clinically improved memory, attention in the single dose studies, and as well as enhanced fear extinction and enhanced contextual memory. And so what's happening there kind of is it was done in a claustrophobia study where people were able to kind of inhibit that fear response and contextualize the information to be a little more rational, which I think is quite quite impressive for methylene blue to do. And then, there's been anecdotal reports a lot because this is fairly popular. It's gotten a lot of hype. And so people have reported to have, a lot of improved attention and
which
focus.
kind of goes to support what was found in the
Yeah.
clinical trials there.
I know it can interact with serotonin in your gut, and so that might be a major component in mood enhancement, and as well as people report enhanced creativity, which probably has something to do with the more neurotransmitter.
That's fascinating.
Yeah.
Enhanced creativity.
Mhm.
That's one thing that I've not seen often reported in anecdotal nootropics.
Yeah.
It's like an enhanced creativity.
Why?
Like,
How does that work? We'd love to try it out for ourselves.
um, but
We try it out. We're gonna try it out. You talk to your
yes,
healthcare professional.
um,
I am my own healthcare
I
professional. Decide that.
professionally care for my health.
Exactly. I pay to do
I pay myself to do that.
my
Okay, so what are the kind of potential applications for those mechanisms that we discussed earlier?
So we kind of talked about this a little bit before, but there's some applications in Alzheimer's, Parkinson's, as well as some improvement in traumatic brain injuries, and as well as there's that mood boost with there's also some mental health factors like depression, anxiety, as well as bipolar disorder, and so that's really cool, and as well as potential cancer treatments that's being looked at with us sensitizing cancer cells to radiation as well as chemotherapy. And there's also some anti-aging,
Ooh,
with mitochondrial function, right?
interesting.
Oxidative
Yeah.
stress reductions and progeria, and as well, kind of what first guy figured out, is help with malaria, even COVID-19 potentially, and Lyme disease. And so, and then there's a lot of other ones as well, like wound healing, pain relief, mast cell activation syndrome, and combining red with infrared light therapy, sulfate analysis, as well as make milk freshness testing, which I with my new job I'm useful.
Yeah.
Water testing the alpha fungus and like diagnostic aid. So there's so many potential applications here, and it's generally fairly safe. But there are some side effects like gastrointestinal upset, headache, urine discoloration, dizziness, confusion, and some high blood pressure risks, as well as serotonin syndrome, and which
Which
can be
is
risked
particularly when combined with other medications.
yeah, with other medications. So if you are on SSRIs or anything of that sorts, please talk to your healthcare professional.
As well as MAOIs.
MOs, yeah. And so, yeah.
And particularly note, please note that that antihistamines are particularly interact with this. So if you're taking an antihistamine, do not even consider taking methylene blue.
Yeah. It would not be very good for you.
It's known to have severe interactions. So.
Hypersensitivity to methylene. And
There are also just another. Please note that there are other cases where there could be issues, like there's a specific genetic condition that can people can have that will um, lead to a poor processing um, of methylene blue, as well as um, potential interactions and reactions to it. So just note that, like, while these are just kind of covering bases, because these are extreme outlier cases for the majority of the populace. It generally has proven really, really safe.
Yeah.
But there are times in which
you need to look at the potential.
So yeah, just make sure that you know yourself, and make sure that you're aware of the drugs you're taking. That's always good.
Yeah. Just don't take drugs randomly. All right.
Don't take drugs that you don't know about.
The ones you do, no matter what it is, then you're fine to take them. Just kidding. That was a joke.
Yeah.
But yeah, so it's a pretty versatile compound. There's long history, very long history, a couple hundred years, and diverse applications. And it's pretty promising, I would say. With its cognitive enhancement, neuroprotective abilities, and as well as it's lots of other conditions that it can help with. So yeah,
I'm sold.
me as well. It's affordable and
Mhm.
available pretty much everywhere as well. So it's
Is it?
pretty, yeah, very widely available.
I would say it's definitely more widely available than most nootropics.
Mhm.
Like
More than the other ones we've talked
the
about.
Ristams are like they're one of those that's like, you have to go to a certain research companies in order to be able to even get those.
Yeah.
Methylene blue is kind of one of those that's like every peptide site ever has it.
Yeah, exactly.
Yeah.
But you probably want to get it at those research institutions anyways,
Yeah. I'm not going to promote any specific ones because I'm not getting paid to do stuff.
But if
So,
someone wants to pay us, we'll promote you. So,
but as long as
Yeah.
I believe in your product, I will not promote you if I do not believe
or
in
you
your
give us
product.
$1 billion.
I'll believe in anything for $1 billion.
We'll
Yes.
we'll make it work.
You can buy me for $1 billion. That's fine.
Yeah. Anyways, on that note, that's methylene blue. So
That is
want your pee to be
methylene.
cool colors, then you should probably take this.
Yeah. If you ever wanted to imagine that your pee was an Easter egg,
Yeah. Or maybe if that your baby's gonna be a boy.
yeah. Or you think it's going to be a girl and you want to convert it to a boy.
Yes,
Yes.
you can at the big
Just take
reveal.
a bunch of methylene blue.
What's the piss gonna be? It's gonna be blue. It's a
Oh, I
boy.
was thinking more of you think your baby's going to be a girl. You want to make it boy. So you take a bunch of methylene blue and then like the blue dye makes it
Well,
boy like because blue obviously means boy and
yeah,
pink
you
means
go up to
girl.
your wife and be like, "Chug it, big boy. I need a boy." You need to put him in sports. You make him do all the boy stuff. Or you
Comes out singing I'm blue dabba dee dabba da dabba dee dabba
seen
da.
that like dancing baby meme.
Oh my gosh, no.
But that pretty much. But yeah, so it's good for either that or gender reveal parties if it's gonna be a boy. So it's pretty. They didn't mention that in the study for some reason. I don't know why.
I like to have a gender reveal party at least once a year.
Once a year. What's the gender gonna be this time? Sorry, what's their gender gonna be?
I just like everyone to know on a continuous basis what my gender is.
Yes.
Every time it's been male, but I still like to keep people up to date.
Yes, just to let them know it hasn't changed or anything.
Yeah.
Oh, very fluid, dynamic individuals, biologically agent. So important to do those things. Yeah. Anyways, I am excited.
Yes.
I will give y'all an anecdotal report to get this stuff.
Yeah, that's one thing that we're considering posting some of is like kind of taking some of these that we've tried and experienced and doing our own kind of anecdotal reports on it and posting that for whatever that's worth and because I know there's just like a lack of reliable research out there and reliable reports
Yeah.
and there's inherently is something a little more trustworthy about a report from somebody whose YouTube channel is at stake.
Exactly. So you gotta make sure
So you're not just going to completely, fake your way through things because, you got stuff writing on it. And whereas on Reddit and whatever else, you don't have
Exactly.
that. So,
and we're not getting paid for it. We're actually using our money to get this stuff.
mhm.
So it's purely for enlightenment. Products. See what they have to offer.
Enlightenment and, dare I say, potentiation.
Potentiation. Indeed.
Mm.
Yeah.
Wow.
Yes, this is where we'll end this podcast. It was a good one. We talked about some incredible stuff, I will say. Vision, tension mechanisms, methylene blue. It really was just like a big impact. Just like bam, bam, bam. Good topic after good topic, I will say. So I really enjoyed today. It was
Yeah,
awesome.
I feel like I could have spent an entire podcast talking about methylene blue. There's
For sure.
a lot of information that we didn't even cover there. Like, there's a whole host of individual studies that I would have loved to delve into, as far as what methods they used and what the results showed, like in detail. And but unfortunately, like, kind of with it being crammed into the rest of the podcast, as well as with you know it being there being so many studies, it's hard to kind of find a way to condense that down into.
Honestly, we should do it. Methylene blue podcast.
Yeah, we should. We could
After
or at least a detailed video on it. Yeah.
for sure.
Yeah.
I'm with you there.
All righty, guys. Well, thank you for tuning in to ThetaWave podcast. And as always, keep riding those theta waves. We will see you guys next time.
Peace.